Okay, so another topic that has definitely not been taught, and in many ways the final part to this is one of the most difficult things that I teach in terms of dynamos and alternators. Fortunately for you, on your mock you don't have anything, or you don't have too much on alternators and dynamos, which is great. So what's the basics here? Well, in the last section we looked that if I've got a current carrying wire, it makes circular magnetic fields. If I put a magnetic field around it, the wire will experience a force. Well, I could make a generator which does the opposite of this, which is if I just take a wire and wiggle it up and down, if I put the motion in, the force, and I've got a magnetic field around, and I've got my length of my wire there, it will induce a current. This will experience a changing magnetic field as I move it in and out of this. All right. Now, if I wanted an alternating current, I'd move it up and I'd get this part. And as I moved it down, I'd get that part. So you can see I can make an alternating current. Now, if I did it with just a single wire, I'm not going to get very much current at all. So what do? We put it into a solenoid. We wrap it as a solenoid, which is just a coil of wire. So that's a solenoid. And we can see that here. And what they're going to do, they're going to drop a magnet through. So we can now see they're showing you the south pole here. That's going to produce this part. And I'll get rid of that because it's the red over the blue is silly. So when that south pole, let's change my colour, gets to say here into the centre, that's going to be this peak here. When the red part gets into the middle, that's this here. So we can see we're making an alternating current by dropping a magnet through. So it shows a reading of 0.12. Explain why this reading here. So the crucial part is I can induce a current if a wire experiences a changing magnetic field. And there's my keywords, but the word changing is crucial. So a changing magnetic field. And clearly this is the wires experience a changing magnetic field as that magnet passes through. It's going to go from weak parts to strong parts and all the way through. So as the south pole moves through the coil, a positive voltage is induced. So when that moves to here, and then now we're going to say the next part. As the north pole moves through the coil, a negative voltage is produced. Done. And if I had this wire connected, because I've got a push, I can then make a current. How could the student produce a higher potential difference? They've got a choice. Use a stronger magnet, it's easier. And the other one takes some explaining though. What I could do is wiggle the magnet inside the coil faster. So rather than just drop the magnet through like that, put the magnet in the middle, wiggle it backwards forwards as far as I can. Now, the second one here won't just make a higher potential difference, it will also give it a higher frequency. So if I was to explain, let's get back here. Let's have that's the rest position. And then let's get my blue. So if I was to just drop the magnet, and let's say we got that as the voltage that we saw. If I was to now do wiggly, 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 move it faster, not only do we produce a higher voltage there, but also because we're moving it faster, we get a higher frequency. So the first one will just work in that example there. If I was to wiggle it faster though, the second one, yes, I'm going to get a high potential difference, but I am also going to change the frequency of the voltage of the current if I complete the circuit. And that's that done.